Right, this is section 4.3 on permutations and combinations. So we can use multiplication to determine the total number of outcomes for a series of events. So for example, to complete a driver safety course, students have to choose 2 lecture style classes, 3 on-the-road practicals, and 2 online courses. Students must choose one of each. How many different combinations are there? So one way to do this, it's actually creating a sample space, is to use a tree diagram. So let's start with the lecture classes. There's 2 of them, so I labeled them L1, L2. Now from there, you could do lecture 1 and then the on-the-road practical 1, or on-the-road practical 2 or 3, or you could do lecture 2 and practical 1, lecture 2, practical 2, and so on. And then after that, you'd have a choice of 2 online courses. So if you count up every tail of this tree diagram, or every root or branch, or whatever you want to call it, you could count the number of total combinations that there are, or you could just do 2 times 3 times 2 and get 12. That's something called the counting principle in probability and statistics. So here's exercise number 1. A nearby park has several walking trails. A map of the trails is shown. How many different ways are there to get from the trailhead to Newton's cradle? So hopefully there are 2 paths from trailhead to Lookout Bluff. There are 3 from Lookout Bluff to Wright's Peak, and there are 3 to Wright's Peak to Newton's cradle. So 2 times 3 times 3 is 18 combinations. At a school cafeteria, 3 choices of main dishes, 5 choices for sides, and 2 choices for dessert. You must take one of each. How many different combinations are there? I ask you to draw a tree diagram, so try that out. So you are going to toss a fair coin 3 times, make a tree diagram to show all possible outcomes. This is what it would look like. You could start with a head or a tail, and then after that another head or a tail, and then after that another head or a tail. So there are actually 8 possible outcomes, and they're all listed on the right. Again, those outcomes can also be called a sample space. So what is the probability that you get at least 2 tails? So there are 4 that have at least 2 tails, so that's 4 out of 8, or 0.5 probability. What is the probability that you get at most 1 head? Again, there are 4 of those. At most 1 head would be 4 out of 8, so another 0.5 probability. Now, a little different. Suppose you're trying to arrange 8 people at a dinner table. How many different combinations of seating arrangements are there? So that would be 8 times 7 times 6 times 5. Now there's a different way to do this, and it's called a factorial. So a very common notation for this type of computation, where you just multiply going down from that number, 8 times 7 times 6 times 5 times, is factorial. And an exclamation point denotes factorial. So 8 exclamation point isn't read 8. It's read 8 factorial in mathematics, and you would do all that multiplication. The reason we do that is because the options for seat 1 are 8. The options for seat 2, after that person's been seated, is 7. Options for seat 3 are 6 people. For seat 4 are 5 people, and so on until you get down to there's only 1 person left for seat 8. Now, your calculator can do it if you go to Math and then scroll over to the prob and go to choice number 4. It actually has the factorial button. So 8 factorial would be 40,320 different ways you could seat those people at the table. So why don't you use your calculator to compute the following? Now, what you might notice is that 0 factorial is actually 1. So how is 0 factorial 1? Here's how. So 5 factorial, 5 times 4 times 3 times 2 times 1 is 120. 4 factorial is 24. 3 factorial is 6. 2 factorial is 2. 1 factorial is 1. And your calculator is saying 0 factorial is also 1. Well, here's how. If you start at 120 and divide by 5, you get 24. If you take 24 and divide by 4, you get 6. If you take 6 and divide by 3, you get 2. If you take 2 and divide by 2, you get 1. And if you see the pattern, if you take 1 and divide by 1, you get 1. So you're just following a pattern, and it logically makes sense. Now to change it up a little more, suppose you have 8 friends and 5 chairs. How many different ways can this be done? So there's 8 choices for the first chair, 7, 6, 5, and 4 choices for the fifth chair. This is a situation where we can use permutations. So permutation is kind of like a cousin to factorials. It uses a lot of factorials in the actual hand-done computations. Now, what about the other 3 people? Don't care about them. They don't get a seat. So permutations. I did give the formula here, the number of ways to arrange in order. So pay attention to that. It's in order, excuse me, n distinct objects in r different arrangements is that formula right there. And you can see factorial is built right into it. Now, the notation for this is you have 2 subscripts, an n and then a capital P and then a subscript r. And you read this, the permutation of n things taken r at a time. So this is also on your calculator. If you go to math, move it over to prob, and it's number 2, you can type in the numbers 8 and 2, or in the case that we have here, the 8p5, or 8 things taken 5 at a time, would be 6,720 ways you could arrange 8 people in 5 different chairs. Now in this one, suppose for an English class you were required to read 4 books from a list of 10. The order in which you read the books doesn't matter. In this example, we are interested in the different groupings of 4 books or combinations of 4 books from among the list of 10 on the list. This is a different type of calculation, but closely related to what we're talking about. I gave you the formula there, still with an n and an r. The notation is NCR, in red, combination of n things taken r at a time. And let's talk about how many combinations there are for these books. So in this context, I chose some of my favorite books. Huckleberry Finn, A Wrinkle in Time, To Kill a Mockingbird, and The Road. In this context, is the same as reading The Road, A Wrinkle in Time, Huckleberry Finn, and To Kill a Mockingbird. Is the same as reading A Wrinkle in Time, The Road, To Kill a Mockingbird, and Huckleberry Finn. Is the same as reading, etc., etc. So the order in which the books you read, the order that you read the books does not matter. So this is a combination. So on your calculator, it would be 10C4, which I believe is choice number 3 on that prob menu. There are 210 different combinations to read those books, 10 books taken 4 at a time. So to illustrate the difference between permutations and combinations, consider a bag with 4 marbles in it. One is red, one is blue, one is green, and one is black. They are all identical except for the color. You're going to select one marble, keep it out, and then select another. So with permutations, we're going to take, there are 4 colors, and we're going to take 2 out. So there are 12 permutations of this. But if you do the same numbers, but with a combination, you only get 6. Now, if you look at the table, what is the difference? Well, with combinations, the order doesn't matter. So where you see a blue and a red, and then a red and then a blue, those actually count the same when it comes to combinations. With permutations, a blue then a red is counted different than a red then a blue. So in combinations, basically the shaded out part here doesn't count anymore. You take about half of them away. That's not always the case, but you take some away. And that's because the order doesn't matter as long as the colors are still the same in that group. Down here is a little table to kind of go over the difference. I like the examples. So an example of a combination, how many pairs can be made from a group of 6 people? Something like Jin and Tom are the same pair as Tom and Jin. But a permutation would be in order. So 6 people are in a contest. How many ways can first and second place be awarded? In this case, Jin first and Tom second is different than Tom first and Jin second. So it actually has more ways, more different permutations. The number of permutations is larger than the number of combinations. That's something to keep in mind. So as an example, the executive board at Bellevue Community Hospital has 12 members. 3 officers, president, vice president, and treasurer must be elected from those 12. How many different slates of officers are there? So first, is this a permutation or a combination, and how do you know? So I wrote that it's a permutation because Jennifer as president, and I think I was making these names up, Tim as vice president, Ellen as treasurer is different than Tim as president, Ellen as VP, and Jennifer as treasurer. The order of officers matters. So what you would do is on your calculator, 12 members, uh, taken 3 at a time, there are 1,320 different slates of officers. To illustrate the difference between this permutation and this combination, 3 members of the Executive Board of Bellevue will be randomly selected to go to a convention in Hawaii. How many different groups of 3 are there? So this is a combination because Jennifer, Tim, and Alan going is the same thing as Alan, Tim, and Jennifer going, and so on. The order of the names does not matter in this case. So this is a combination. So what you do on your calculator is do 12 people, C3, groups of 3, and there are 220 different groups that could go on that trip. So here is exercise number 3. So the first thing I would do is determine if you need a permutation or a combination, and then use your calculator or some other computing device and figure out the number of ways these positions can be filled. So this is a permutation because they're filling in positions. So being the day nursing supervisor and being the night nursing supervisor and nursing coordinator is different depending on who's filling them. So there are 2,730 different ways to fill those 3 spots. Number 4, 15 qualified applicants for 5 trainee positions at Bellevue. How many different groups of trainees can be selected? So this is actually a combination because it doesn't matter in which order these 5 people are picked. So if it doesn't matter, it doesn't matter what order these trainees are picked. So this is a combination. 15 people taken 3 at a time or in groups of 3. So 455 different groups. Applicant pool for 6 management trainee positions at Bellevue consists of 7 women and 5 men. How many different groups of applicants can be selected for this position? So this would be 12 people taken 6 at a time. I got the 12 from 7 women and 5 men. The 6 is the 6 management trainee positions, so 924 groups for letter A. How many different groups of trainees would consist entirely of women? So this would be the 7 women taken 6 at a time. So there are only 7 different groups of women, 7 different ways that the trainees would all be women. Sorry, I misspoke there. If the applicants are equally qualified and the trainee positions are selected by randomly drawing the names so that all groups of 6 are equally likely, what is the probability that the trainee group will consist of all women? Well, in this case, 7 groups are all women out of 924 different total groupings. And if you do that, that's about a 0.008 probability that a group of 6 would be all women. So not very likely. 25 people, 10 males and 15 females, entered their name for a drawing at a local store. First place is a $50 gift card. Second place, 25. Third place is 10. If each person has an equal chance of being selected, how many different ways can these cards be handed out? This is a permutation because the order does matter. Getting the $50 gift card is different than getting the $25 gift card and so on. So there's 13,800 different ways. How many different groups of winners are there? This would be a combination because we're just talking about groups of winners. It doesn't specify the order in which these can be handed out. You're considered a winner whether you're 3rd place or 1st place, I guess, in this context. How many different groups of winners are there that would be all females? So this would also be a combination. Again, it just says group of winners. So if 1st, 2nd, 3rd is a group of winners. So it's 15 females taking 3 chances of winning. So 455 groups of all female winners. This is the Unit 4 overview going from Unit 4.1 down to Section 4.3, which we just finished on permutations and combinations. Let me know if you have any questions. Thank you.